Okay, so for our next task number 3, ISATAP tunnel on Windows 7, and this is for client to network tunnel. So let's go back to our diagram real quick. As you can see here, so what's going to happen now is our Windows 7 machine, 2 of them, is going to try to discover the default router, just like how it normally happens on the regular IPv6 network. But instead of doing that natively on IPv6, it's going to happen across the ISATAP tunnel over IPv4 network. And this is because the ISATAP tunnel allows R2 to perform router advertisement. So that way, 2 of our machines will be able to receive the prefix, as you will see in a second here, and actually do the auto configuration and derive its own IPv6 address. So that's one thing that's unique about the ISATAP tunnel. And there's actually 2 ways for these end device to discover their default router. And one is dynamically using a DNS query. So the end device will perform a DNS query to the well-known DNS name, and that will need to be resolved to the default router IP. So here we're going to have to create a DNS record, or actually we already have that created, that will map a well-known name, as you can guess. The name is ISATAP dot your domain basically, so we have our .labminutes.com here, and that's mapped to the router R2 on our DNS server. So that's the first option. Now the second option is to hardcode or manually configure the default router IPs to the end device, so you know exactly which device to contact or build the tunnel to and use it as a default router. So first we're going to try the dynamic method with the DNS resolution. So we need to configure R2 as a DNCP server for VLAN 123 with the default gateway of 123.2 with the DNS server point to our Windows 2008 server at .32, and then give it a domain name labminutes.com. And to kind of keep things clean with the tunnel 1 facing R3, we're going to create a tunnel 2 that will be facing the Windows 7 machines, and we're going to use the prefix 2001.222/64. So let's go ahead and have those configured first before we do anything with the end device. So on R2, we have to do IP DSCP. Let's exclude 192.16.123.1 and 192.16.123.63. So the first IP will be .64. And then IP DSCP pool. Let's call it VLAN 123. Our network is 172.16.123.0, 255.255.255.0. Default gateway 16.123.2. DNS server is 16.123.32, and the domain name is LabMinutes.com. Okay, next we have to create a new tunnel interface that will be facing the test machine with the subnet or prefix of 2001.222/64 with using EUI. And then we're going to source our tunnel interface from Fast Ethernet 00. And we need to make sure the tunnel mode is IPv6 IP ISATAP. Okay, and we're going to also advertise that tunnel interface subnet on our IPv6. So R3 will be able to learn that subnet as well. Okay, so next on our Win7 Test 1 machine, we're going to have to enable ISATAP tunnel and connect it to 2001.222 subnet, and this is going to be done through the DNS resolution method as far as discovering the router R2 as the default router. So let's get on to our Win7 Test 1 machine and bring up our command window. We need to make sure that we run it as an administrator since we're going to be changing the network settings. So we need that privilege. So the command is netsh interface, and then if you question mark, you'll be able to see the option. So we're going to be dealing with ISATAP. So let me do up arrow. ISATAP. You can do show. So look at the current status of the either router or state. So if you do show router, you can see everything is at default. And then if you do state, and by default the state is disabled. So to enable that, what we need to do is the command netsh interface ISATAP. Instead of show, we're going to do set state enable. Okay, it came back with OK. So if you go back and check the state again, you can see now it's set enable. And now just to capture that DNS resolution we talked about I'm going to hop onto the DNS server owing to 2008. First, to show you that we have a DNS record, configured for the name ISATAP, mapped to 172.168.123.2, which is our R2 Fast Ethernet 00 IP. And to capture the DNS packet, let's run Wireshark start, and we're going to put up a filter for the DNS. And let's also do one more thing on R2. See what kind of debug we have. We have the ICMP debug already, so let's also enable debug IPv6 ND for the neighbor discovery, so you can see the whole process of the neighbor discovery that's going to happen. Now, getting back onto our test machine, we're going to disable and enable the network interface. So on the adapter setting, disable, and let me clear the background here on R2 a little bit and enable. And then let's take a look at the packet capture on our 2008 server. And as you can see here, there's a DNS query coming in from .64, which is our Win7 test 1, asking for the IP for isatap.labminutes.com, and our DNS server replies with 123.2. Okay, so once the Windows 7 knows about which IP to use to build the tunnel to, then let's get on to our R2, and let me kill the, actually let's leave the debug on, but let's scroll up. And you can see right here, oh, actually, you know what, let me disable that. And right here, R2 received a router solicitation message. Actually, it's this one right here, and you can tell that's because the source IP is the link local that ends with 7B40, and that's equal to 123.64 in IPv4 address. So that's coming from our Win7 machine, or test 1 machine. And this is just to ask the router to send back a router advertisement message. So basically the end device is being proactive, asking for those information. And you can see R2 reply with the RA, which is router advertisement, with the information that the end device will need, such as MTU 1480. And most importantly is the prefix that we need to know to auto-configure the IP, which is 2001.222. Okay, so that went back from R2 to the Windows 7 machine. And now if we get onto our Windows 7 machine and do ipconfig all, and here you can see with the adapter isatap.labminutes.com, so it learned that through the DSCP. Here with the IPv6 address, it has already auto-configured itself with the prefix that it learned as part of the RA, 2001.222, and then the exact same format that's mandated by the ISATAP, which is 5EFE, and then ends with its own IPv4 address, which is 123.64. Link local is the same way, but instead it begins with FE80. And you can see here the default gateway is also using a link local address that points to R2, and that's being learned as part of the DNS resolution. And here's the IP of the DNS server. Okay, so if you do route print, you see that for IPv6 it has the default route pointing towards the R2 link local address. Okay, now if you're trying to ping the R2 link local IP paste, you can see for some reason it's not pingable, but that's okay. So now before we do more test ping, let me kind of restart our packet capture here. So continue without saving, and then this time instead of pinging the R2 link local address, we're going to ping its global address, which is 2001.222. Let's see, let's hop onto R2 and then show IPv6 interface TU2. So we're going to ping this IP right here. So 2001.222 5EFE, and instead of typing out the R2 IPv4 address in hex, we're just going to type in the original IPv4 address, which is 123.2, and you can see that it's pingable when you ping the global address on R2. Okay, so let's try to ping another IP. This time we're going to ping IPv6 address on its loopback 1, which is 2001.2.2. Okay, you can see that it's pingable as well. Actually, let me go back and do a debug IPv6 ICMP, and then let me do up arrow, ping its global address, and then let's try and loopback 1 more time. And just to get a little further, we can even try to ping R3, which is 2001.3.3. You can see that it's pingable as well. Okay, and then we can do trace route to R3 just to see what it looks like. While that's running, let's take a quick look at the ICMP debug output. Here with the echo request coming from 7B40, so we know that's coming from the Windows 7 machine. And here, this one is going towards R2 tunnel interface. Okay, and this one going towards R2 loopback 1. You can see it replies as well. If you hop on R3, R3 receives pretty much the same thing from 7B40 towards 200133, which is R3 loopback 1. Okay, so let's go back and check out our trace route. As you can see, our trace route first hop is R2 tunnel 2 interface. And then once it gets to R2, R2 knows how to reach R3. So R3 shows up as a second hop. Okay, so just to refresh our memory on the diagram here, our Windows 7 test 1 coming across tunnel 2 because it used R2 as its default router. And then from R2, it goes to R3. And this is because we advertised tunnel 2 subnet across IPv6 to R3. And we can still see the same thing right here as well when we're trying to ping from our Windows 7 test 1 to R3. You can see as far as the encapsulation, the source is its IPv4 address, which is 123.64. But instead of sending that directly to R3, it goes through the first hop, the default router hop, which is R2, and that's why on the destination IP, instead of R3 IP, we have the R2 IPv4 IP. Okay, but as far as the ultimate destination is actually the R3, which is 200133. Okay, same thing with the reply. The reply is actually coming from the R2 and not R3 as far as the IPv4 encapsulation or address and encapsulation. Okay, so that is for when you want the end device to use DNS resolution to discover the default router. So now the next part of our task, which is the manual configuration on the Win7 non-corp, which is our second Windows 7 test machine, we need to enable ISATAP tunnel and connect that to the 2001.222 network or the tunnel 2 subnet on R2, but instead we want to manually configure R2 as the default router this time. And then we need to verify the reachability and make sure it can reach all the way to R3 loopback 1, 2, and 3. Okay, so now on R2, let's clear the screen. Make sure we still have the debug. Okay, so let's do debug IPv6 MD. Okay, so we can watch for that conversation on the neighbor discovery. And now getting on to Windows 7 non-corp, I'm going to bring up the command window. Again, make sure we run as administrator. And same type of command to enable ISATAP interface. So netsh interface, ISATAP set state enable, and then we're going to have to hard code the router address, and that would be netsh interface ISATAP set router 172.16.123.2. Okay, and now if you do, let's do up arrow netsh interface ISATAP, let's do a show command before we move on. So first let's do show state. Sure enough, it's enable. And then if you do show router, you can see here the router name is 172.16.123.2. Okay, and looks like we got a whole bunch of debug messages. You scroll up right here. The same thing as what we've seen previously with the router R2, received a router solicitation message. This time it's coming from 7B3F, and 3F is equivalent to a .63 IP, which is what we have configured. So let me do IP config all, and look at the interface. We have that hard-coded to 123.63, and that's equivalent to 3F in hex, so we know it's coming from the Win7 non-corp. And then R2 reply with a router advertisement with MTU and the prefix. So with that information, that means Win7 non-corp should already have the auto configuration completed. And let's see if we can find the correct interface right here with the tunnel adapter ISATAP with the IPv6 address 2001.222, 5EFE 172.16.123.63. Okay, and then the corresponding link local address. Okay, and same thing if you do route print, it has the default route pointing towards R2, link local address. And now let me restart this real quick. And here, if you're trying to ping R2 global address on the tunnel interface, or the tunnel 2 interface, which is 2001.222, 5EFE, 172.16.123.2. You can see that it's pingable, which is the global address of the default router, R2. And then we can even try to ping .64, which is our Win7 test 1. You can see that's pingable as well. And that basically tells us two Windows 7 machine can communicate directly without going through a router, because it's a point-to-multipoint kind of tunnel with the ISATAP. And then we can also try to ping R2 loopback 1, 2001.22, and finally R3 loopback 1 with 2001.33, and then R3 loopback 2, and then R3 loopback 3. Okay, again on the Wireshark, let's see what we have captured so far. The last sets of ping that we did was going to R3, and again using the autoconfig IP address from Win7 non-corp with their 7B3F going towards 2001.3023, and of course the first hop, the first tunnel destination would be the router 2. That's why we have 123.2 as our IPv4 destination on the outside IPv4 header, while the IPv6 header is this original source and destination IP from the Windows 7 going towards R3. Okay, same thing as with what we observed earlier with the other Windows 7 machine. And same thing if you look at R3 ICMP debug output, you can see the source IPv6 IP is coming from 7B3F going towards its loopback 3. And that's pretty much complete our task number 3. So now you've seen that with the ISATAP tunnel, in addition to providing network-to-network connectivity between IPv6 networks, you can also use ISATAP tunnel to provide the client-to-network connectivity, or actually even client-to-client IPv6 connectivity as long as those clients support ISATAP tunnel and run dual stack. Okay, so that wraps up our video on IPv6 ISATAP tunnel. You can visit our website to view an extensive list of our lab videos and sign up to get access to additional lab contents. Thank you for watching LabMinutes.com, and I will see you guys in the next video.